Hi everyone, welcome to my first video in this Verilog series. So today I will be discussing something about the different value sets in Verilog. As we are already aware, there are four different value sets defined in Verilog. 0, logic 0, logic 1, logic don't care, and logic high impedance, Z. So logic 0 is nothing but we are going to assume it as logic low or false condition. Logic 1 is nothing but it's logic high or true condition. Logic don't care is nothing but it's an unknown. And logic Z is nothing but it's an high impedance. High impedance. Okay. So generally, whenever we assume logic 0 and logic 1, everyone will be having that enough clarity. But now in this video, let us try to analyze how the simulator will analyze this different logic sets inside any Verilog compiler or anything. So in the simple terms, if we want to discuss what is a don't care, it is nothing but either 1 or 0. And in the simple terms, if you want me to explain what is an high impedance, it is nothing but it's neither 1 nor 0. So this will be the conditions. Okay. Now let us try to assume how the simulator will analyze analysis of logic sets in Verilog. Okay. So generally, the first one, let us start with a basic one, the logic 0. So, so whatever the analysis which I'm going to start here will be nothing but we are going to, as it is a simulation, we will be considering the ideal analysis. We will be considering the ideal cases. So what does it mean by the ideal cases? First one, no delay for the buffer. No noise margin into consideration. Okay. So now let us come back to a scenario where how the logic 0 is being analyzed by the simulator Verilog, in Verilog. So whenever we are considering anything, let me just assume a buffer. So, so what is the functionality of a buffer? Whatever the input we are giving, we are going to get the same output. Okay. So as we have discussed earlier, by the till the end of this video, whatever the buffer we are going to discuss will be nothing but the ideal buffer. So, so now if at all I'm giving an ground here, the output will be 0, which is equals to logic 0. Now let us analyze how the logic 1 works. How the logic 1 works. Let me again assume a buffer. Let me again assume a buffer. So let me give the VDD as the input. So just to analyze, it's a VDD. So whenever I'm giving the input of VDD to a buffer, obviously whatever the output which I will be receiving will be nothing but 1, nothing but the logic 1 or logic high, anything. Now the next one comes, the most interesting one is the logic don't care. The value set don't care. Value set. Okay. So what does it mean by don't care? Already in the above discussion, we made a statement like logic don't care is nothing but either 1 or 0. So in order to analyze this, let us go with an idea like how the simulator will work. So let me assume a buffer over here. Let me assume another buffer over here. So here let us consider whatever the input which we are giving is nothing but VDD. So obviously as per our above analysis, the output will be 1. So here let us assume whatever the input which we are giving is nothing but ground. So the output this one will be the 0. Now when both of them are connected, there is a fight between 1 and 0. As we have considered everything to be ideal, the simulator and everything to be the ideal thing, there is a fight between 1 and 0. So the simulator cannot decide which one comes first and which one comes later. So obviously initially whenever the simulator is unable to decide between 1 and 0, so obviously it will give an unknown because it doesn't know who will win the race. So that's how we will get something called as unknown or don't care. Logic value set don't care. So now if we can go for the logic high impedance value set. Logic high impedance value set. So generally for this already we made a discussion like it is nothing but neither 1 nor 0. Okay. So whenever we call this one as neither 1 nor 0, automatically it is nothing but, so let me take the help of an tri-state buffer. So what does it mean by the tri-state buffer? So let us assume there is a buffer. Let us assume there is a, sorry, let us assume there is a buffer. So this will be the input, this will be the output. So this will be the enable. So generally how the tri-state buffer works, whatever the output will be assigned with the value of the input only under the condition when enable equals to 1. But what if enable equals to 0? The output, there will be no connection between the input and the output. So which leads to neither 1 nor 0 because the simulator is not in a position to analyze whether that is 1 or 0. So that's the reason we will get a value high impedance. So this is how the simulators will analyze all the different 4 logic sets. This analysis has been very important or crucial in whatever my experience to debug so many things with respect to this. So thank you. Thank you for your attention. If you are having any video ideas, please do comment below. I will be always ready to do something very new with respect to this. And this Verilog series will be continuing, and I will try to make the as enough videos as possible. Please like, share and subscribe to Beacon Preceptor and wait for more very good, happy, knowledgeable content in Verilog and digital electronics. Thank you. Thank you everyone. Thanks once again. Have a great day.